Hello everybody. I am Anish Karki, currently studying computer science with artificial intelligence at Sonway College, Kathmandu, which is located in Moiti Devi, Kathmandu. So, today I'll be discussing about Bayes theorem, which is a part of probability. Probability is a very vast topic, and there is still research going on. We use probability in daily life, but I will not go dive into whole probability subject. But I'll be talking only about Bayes theorem and its uses in various fields, mainly in machine learning and AI. So let's start. So in this session there will be chapters. Before starting Bayes theorem, I'll be talking about why is probability here, how it came into existence, and why do we need in daily life. And then we'll go into intro to Bayes theorem, introduction to Bayes theorem. Then we'll see the uses of Bayes theorem in various fields, such as finance, health, artificial intelligence, and many more. And we'll be discussing and finally I'll be discussing about future uses of Bayes theorem, what where we can use Bayes theorem in future. So let's start the topic. So why is probability here? In life we are not 100% sure what will happen upcoming time. Suppose we don't know what will happen 10 minutes after now. So what we do is we assume based on the evidence. Suppose there is a dark cloud in the sky, and there is a wind blowing, so we can assume based on those evidence that it might rain. So, and while we calculate those assumption into mathematically, it is known as probability. So, probability, suppose there is a coin toss and we don't know what will be the result, but we can find the probability of becoming head and becoming tail. So that is probability, and we use probability in daily life, even while going to college, while choosing the way, and everywhere we choose probability. Probability is not a just a modern mathematical concept. It has been with us since the evolution of human being. And let's go with examples. And when there where we were Homo sapiens, then they might have thought of, like, if we hunt a big animal, the probability of getting meat is higher. So at that time probability was not concept was not founded, but it was used by uh, our ancestors unconsciously. So if they have hunt a big animal, they can get bigger meal meat. So that is probability. And next one is when they were moving from one place to another, they might have seen the river and a wetland, and because of that there is a probability of finding water and fertile soil for growing crops is higher, so that life will be easier there. So they use probability to settle in a new place, uh, and more. So probability has been with us since the beginning of evolution. And how probability and we have used it unconsciously or without mathematical, but how probability became mathematical. So while early human relied on institution and observation to make decision, the need of quantify uncertainty led to the formal development of probability theory. The shift began in 16th and 17th century when mathematicians turns in their attention to games of chance such as dice and card. It wants to say that and before earlier in 16th and 17th century, people used to play card and dice as gambles. Gamble were popular, and some people might have thought of, how can I win this game? How can uh, I be assumed I can be correct, so that I can earn more money? So because of that, the person named Gerolamo Cardano, he is one of the mathematician and who work on one of the mathematical first person to work mathematically in probability, and he have written the book on games of chance, which is based on finding a right order in dice and cards, so that we can win in the game. So it was a curiosity that makes him uh, go dive in probability. And similarly, after certain times, there were people like Blaise Pascals and Pierre de Fermat, and they were those they though Gerolamo Cardano had worked on the book of Game of Chance, he hadn't done it mathematically. But Blaise Pascal's and Fermat uh, use mathematical knowledge in probability to find problems of point. It is one of the uh, uh, thing they have done to find the uh, likelihood to win the game of cards and dice. Yeah, and yeah, and because of that, the probability became more mathematical. And though it was mathematical, but it was not done more theoretically. So there was a person called Pierce Simon Laplace, and he is also known as the founder of modern probability theory. Though the previous person have done started probability with their knowledge, he is the person who uses uh, who help transform probability theory into powerful tool for making prediction and analyzing uncertainty, laying the groundwork for modern statistics, machine learning, and data science. So, though the Gerolamo Cardano started the probability mathematically, Laplace is known as the founder of probability, founder of modern probability theory. So this is about probability, and up to now we have I have talked about that how probability was used in daily life by us in when we were homo sapiens, like our ancestors use it in their daily lives to source food, to source place, and many more. But mathematically, there were people who utilized probability to win games in cars, and suppose let's say to win in gamble. So because of that, there was a birth of probability, and similarly other people have worked on this, and so on. And Laplace use those mathematicals in theoretically laying the groundwork for modern statistics, machine learning, and data science, and because of which probability is used in many fields. And so this is the history and history of probability. And now we will dive into Bayes theorem. It is one of a part of probability, and this is introduction to Bayes theorem. So once probability became a mathematical tool, it opened the door to even more advanced concepts. There are many advanced concepts in probability which we use in daily life uh, uh, to make our life easier and to predict many things. And one of these is Bayes theorem, which allow us to update probability when new information become available. Uh, so it was introduced by Thomas Bayes, and this is the formula of Bayes theorem. And before diving into the formula, let's start with example. What is Bayes theorem actually? So imagine you are trying to figure out something, but you are not 100% sure. Suppose we want to choose something between two things, but we are not 100% sure. Suppose there will be head or tail. We are not 100% sure. It has 50 and 50% of chance becoming both. And then we get clue, like suppose while coin toss it, we got a clue that there is something on head, or there is something we could prove, and that makes Bayes theorem. And suppose, let's start with example I have written. So suppose we need another planet to extend humanity reach, and we have two options, Mars and Venus. Mars and Venus. So which one should we choose? Which one should we choose? And we are confused because both Mars and Venus might have possibilities, and so we have 50-50% of chance choosing it. So there comes Bayes theorem, and first we will guess both Mars and Venus have equal probability of being better. So Mars is also 1 by 2, Venus is also 1 by 2, that is 50-50% chance, and we are still confused which to choose. And then now the Bayes theorem play the role. We'll given the hint, we'll search for hint or update or data, new data, so that we can mm, have the more probability in one of the items or one of the choice. Let's say Mars. Mars is relatively closer to Earth. Mars has thin atmosphere. It's not extreme as Venus, and Mars has evidence of liquid water. Mars has a uh, around 3.5 billion years ago or something like that. There was a river flowing in Mars, but due to its low gravity, life was not able to sustain. Otherwise, it would have been the same as Earth. So there is high possibility of life. Mars is cold because Mercury, Venus, Earth, Mars. It comes after the Earth, so it is cold but manageable than Venus. So these are the hint of Mars, and then we will dive into the hint of Venus. So in Venus, Venus is extremely hot, enough to melt lead. Venus has harsh environment, make it far less sustainable for exploration of for our colonization. Venus has thick toxic atmosphere. The atmospheric pressure on Venus is 92 times that of Earth. So based on factual clues, we estimate the chance of Mars being a good choice given this hint is 80%. The chance of Venus being a good choice given this hint is 20%. So it says that the characteristics of Venus, Mars is a bit more better than of Venus. So which give us hint that Mars is 80% more better to sustain than Venus. And this is where we use Bayes theorem. So let's go into mathematical way. So probability of Mars is 50%, which is 0.5. Probability of Venus is 50%, 0.5. So before we get hints, we have the probability of 50% and 50%. So now we get the hints. Probability of getting Mars, like probability of having Mars based on hint is 80%, which is 0.8. Mars is good choice given the hints. And probability of Venus based on hint is 20%, which is 0.2. Now we will find the probability of hint. Total hint is probability of Mars based on hint into probability of Mars plus probability of Venus into probability of Venus based on hints, which will get the probability of hint is 0.5. Now we will use Bayes theorem. So Bayes theorem is probability of A is to B equal to probability of B is to A multiply probability of A divided by probability of B. That is probability uh, of being probability of A being true given A, and and for first we will use Bayes theorem for Mars, and we have done probability of Mars based on hints, probability of hints uh, on Mars. So we get 0.8%, and for Venus we get 0.2% by using Bayes theorem formula. So based on that, due to hints, we'll be using Mars as our priority to extend our research or humanity. Uh, so what we what we find is, before Bayes theorem, there were just probability, and we don't know which to choose. And because of Bayes theorem, we get hints, and we will calculate those hints mathematically and find out which will be the better option. And since with our solution we get mass as our better option, and that is how we calculate Bayes theorem. And not only here, suppose we want to calculate it will be rain or not, and there is 50% chance and 50% chance of being rain or being not rain. Then we look for hints. Suppose there is dark clouds, so suppose there is wind blowing, and because of that hints we might our probability of choosing something might increase, will increase. Suppose based on dark clouds and other things, the probability of rain will increase to 70%, and other will probability of not raining will decrease to 30%. And we will take our decision based on those calculations. Suppose then I will not wash my clothes today, because there might be rain, there is 70% chance of being rain. So this is the uses of this is Bayes theorem. And since the probability of Mars being a good choice 80% is significantly higher than Venus 20%, we can confidently choose Mars as our destination. The example demonstrates how Bayes theorem helps us update our beliefs and make better decisions when new information becomes available. So Bayes theorem is a powerful tool used in many fields to solve real world problems. So we are using Bayes theorem daily life, but unconsciously we are using it. And if we use mathematically, and it will be very helpful for us. So now let's talk about formula and how this calculation is done. So first we were given probability of A and probability of B, and second is probability of B is to A, probability of B being true given A, and probability of A is to B, that is probability of A being true given B is true. and and so on. We need to find out probability A is to B, that is probability of A being true given B is true. It's like probability of choosing Mars based on hints, and we'll get the formula of probability of A multiply probability of B being true given A, and which is divided by probability of B. So this is how we calculate Bayes theorem, and it is very simple. First we need to find probability of A and probability of B, and we'll and this is like a hint. Probability of B is to A, and probability of A dash B is like a hint we get, and based on those we will calculate the Bayes theorem. And uses of Bayes theorem, and where do we use Bayes theorem? So firstly we use Bayes theorem in AI, uh, and we'll talk about in Bayes uses of Bayes theorem in AI in later also, so I'll not be describing this now. And second is finding a medicine, finding a right medicine. And third one is stock market. So while taking decision on certain stock, suppose I need to buy stock, and one is of let's say Tesla, and another one is Nvidia. So which one should we I choose? Oh no, let's choose both of same category. So let's say I need to buy a share of in car industry. Let's say One is of Ferrari and another is of Tesla, and they are both good uh, good in their markets. And so what should we choose? And first, our assumption is 50-50%. Then we look for hints, and since uh, the world is going uh, in zero emission of uh, fossil fuels and utilize and more utilizing of greenhouse gases. So and based on the hints is in future we will be using electric car and more. So I'll be buying Tesla stock. So this is how we can use Bayes theorem in stock market. And autonomous vehicle, I'll be also discussing about it later. Another is in space, finding a which might be a better place for us to have our research or many more. We can use Bayes theorem there. And biology, such as protein folding, and we can use that. uh, uh, Suppose there is two molecule, and there are one molecule and there are many molecule. So we need to okay, let's say there is molecule A and there is molecule B, and we need to choose uh, uh, one molecule for to make certain type of drugs, and we don't know which to choose, and we'll use Bayes theorem. We'll see their quality and we'll see their characteristics, and based on that we'll choose one. So this is how we use Bayes theorem in biology. And so let's talk about Bayes theorem in artificial intelligence. So one of the most famous machine learning model, let's say, is naive-Bayes classifier, which is used in supervised learning. Uh, it's like it is used in many field. This is one of the machine learning model based on Bayes theorem, and it is used in spam filtering. Suppose there is mail uh, mail which might be a spam, and we will look, and it might be spam or it might be spam not. So we will look for hints, and suppose there is free, win, and prize written in the mail, and it is high probability of being spam. So we'll do spam filtering. We can do sentiment analysis in during post like Facebook post. If the Facebook post contain, it might be good or bad, so we'll be deleting the bad one. So if the post content bad, terrible, and hate, and like those type of language, then we will uh, uh, choose that certain post as bad, and we can delete it so that it won't harm people mood or more. So we use for medical sentiment analysis and medical diagnosis, and we look for certain symptoms. Suppose he has a fever or not, and we look for certain symptoms, and because of which we can find out he had certain disease or not. So there is a naive Bayes classifier is like a part of Bayes theorem, and it is used in these fields. And another is Bayesian Bayesian networks. So it is mostly used in medical diagnosis also. Like we need to find out a person has a COVID or not, and we will, and first we are 50-50% sure either he will have the COVID or he will not. So we will look for hints like if a person has the flu or not, if a person has a fever or not, if a person has cough or not, if person has common cold or not. So based on that we will use Bayesian network to find out person has a what is the probability of we'll find the probability. We cannot be 100% sure, but we'll find the probability like 70%, 30% or more. So this is how we use Bayesian network in daily life in artificial intelligence. And third one is reinforcement learning. It is one of the hot topic, and as well as it is one of the most important topic in the field of AI, because if you see the large language model of ChatGPT, it is doing better because of reinforcement learning. And reinforcement learning is simply uh, when a machine is learned by its own mistake, so it is uh, reinforcement learning. So and that reinforcement learning is used in robotics, like if a robot has to take decision with which decision he should choose, and there is 50% chance, and he will look for hints and which will be the better or give the more probability of being better choice, he will use that. And it was used in AlphaGo. It was one of the project led by DeepMind. So during Go games, while taking the decision by that machine learning model, it look for hints, and based on those hints, based on, and it will calculate the probability, and which probability is higher, it will take that decision. So and another is stock market, as I already said, how we can choose better stock for us using Bayes theorem. So this is how we use it. So in reinforcement learning is one of the key for artificial intelligence, and we use Bayes theorem in reinforcement learning. And another is anomaly ano- anomaly detection and fraud detection. So there, as I already said, there might be a fake news or fraud in online. So we cannot be sure that a particular person is fraud or not. But based on hints, we can find the probability of he being a fraud, uh, and we can put some threshold, like if that probability rose from 70%, we'll ban his account or something like that, so that we can be free from fraud detection. So this is the uses of Bayes theorem in artificial intelligence. And there is not in just artificial intelligence, and not in just like technical field, Bayes theorem is used uh, everywhere. Even during World War II, it was used to crack encrypting German code, because the German were sending codes, and about the way to target next. And at that time, during Turing test, they uses Bayes theorem to find the probability of uh, those uh, those code being certain words using Bayes theorem. Bayes theorem is even used by animal, even doing mating choice. Suppose let's not say mating choice, even we use Bayes theorem to choose our relation. Suppose there is a goal, and for us every goal is first, every goal is same, we they all have same probability of getting being better. But then we look for hints. Suppose she have sweet character, suppose she have different character, suppose she is helpful and more. So based on that hint, we will find certain person better, and we use Bayes theorem for that. And we use Bayes theorem for weather forecasting. And even Bayes theorem was used uh, in many field. So and there is a quotation too: the more evidence you collect, the smarter decision you become. It the more evidence you collect, the smarter decision become. The more evidence you collect, the smarter decision become. So we need to collect more evidence so that we can have the better probability of next thing. And now I'll be talking about future uses of Bayes theorem. So in future, where we can use those Bayes theorem. So first thing is the picture you see is about quantum computer where uh, there is not bits but calculation is done in atoms. So how can we use Bayes theorem in quantum computing? Firstly, quantum state is unknown, and we don't know. Quantum state is unknown is like simply like we don't know where that state will be. Like 0 and 1 can be in any place. So uh, we'll need to estimate based on measurement. You know, at first we are 50% of sure that it will be in that certain place, and we'll need to estimate based on measurement, and we'll look for hints similarly as before, and we will calculate that state. And another thing is quantum error correction. Quantum computers suffer error due to noise, and due to which calculation might get wrong. So it need to be corrected, and we will use Bayes theorem to find those noise based on hints, so that we can correct it. And second one is wormhole and theoretical physics, and it is not yet uh, uh, like it is Bayes theorem won't uh, be 100% sure that wormholes exist, but if it will exist, then we can use Bayes theorem. Suppose we can identify possible wormhole based on operated data like gravitational behavior. Like we might not be sure that it will be a wormhole, but we look for hints like gravitational force, and black hole and wormhole gravitational pull might be different. So based on those hints, we can find the higher probability of it being the wormhole. And so this is how we and not in this we can use Bayes theorem in many field, and we are using Bayes theorem in our daily life. So so it don't so Bayes theorem don't come. And at the end what I want to say is Bayes theorem don't confirm everything. Like it won't say it will be 100% sure, but based on operated data, based on hints, based on evidence, it analyzes the likelihood of it being true. So thank you for watching, and I'll be uploading these slides in uh, I'll be uploading these slides also. So if you have any further question, you can ask me. Thank you, everybody.